I'm Ray Barretto. I am a chemistry professor at Purdue University Northwest in Westville. I work with water contamination by organic and pharmaceutical compounds. Pharmaceutical and organic contamination of water has become such an issue publicly that it was actually addressed last year by Stephen Colbert in the Late Show. Essentially, the problem is that organic and pharmaceutical contaminants can find their way into the water stream either through contamination runoff from factories and farms, through leakages in storage facilities, or through unmetabolized pharmaceuticals finding their way through raw sewerage into the water treatment, into the water stream. As these compounds make their way to treatment facilities, we find that most treatment facilities fail to properly address and eliminate these compounds, and as a consequence, they tend to pass undegraded through the treatment systems into the aquatic environment where they can accumulate over time. Now, while the health concerns or the health risks of these compounds are not completely understood, we know that these compounds do not normally appear in the environment, and it is not unreasonable to say that any compound that does not normally show up in an aquatic or in a water system, if it appears in a system of any concentration greater than 1, or greater than 0, I should say, that such a compound should be of concern. Compounds that we are interested in or that are being monitored in one form or another are polyaromatic hydrocarbons, PAHs, oxygenated hydrocarbons and halogenated hydrocarbons, pharmaceuticals such as analgesics, antibiotics, and narcotics, and endocrine disrupting systems such as androgenic and steroidal compounds, plasticizers, herbicides and pesticides, and other endocrine mimicking compounds. In order to try to address this problem, we have tried to apply photocatalytic chemistry. In order to do this, we take our substrate, introduce it with titanium dioxide and oxygen, and then expose it to light at an energy of about 300 to 350 nanometers. We found that these compounds are very readily degraded, and we were very surprised to find how easily they could be degraded using these systems. Excuse me. We then designed a continuous flow photocatalytic reactor where the titanium dioxide is now immobilized on glass beads. The oxygen is introduced through a diffusion system, and the light is provided by nothing more than your standard Walmart fluorescent bulbs. And we found that this reactor was surprisingly effective in degrading these compounds. We were able to design the reactor, and we patented it last year, and we have been looking at ways of applying the technology. We found that the reactor was capable of destroying up to 1 milligram per liter of substrate, which is usually which is a concentration which is far higher than one normally sees in a contamination stream, where the contaminants are usually less than half that, about 500 parts per billion or less. The reaction is catalyst limiting, which means that as the concentration of the substrate goes down, the catalyst that is present will be more effectively able to degrade the remaining substrate. And that if the intensity of the light is increased, not the energy or the wavelength, simply the intensity, we should be able to increase the substrate degradation significantly. This last summer, we were trying to increase the compounds that we were able to observe these photocatalytic effects. Initially, we were looking at water-soluble organic ethers, and we found that each one of these can be photodegraded using the titanium dioxide oxygen system. Both the compounds and their degradation products could be very easily destroyed. This summer, we decided to extend the processes to analgesics. We looked at acetaminophen, ibuprofen, and naproxen, and a series of antibiotics and stimulants, specifically tetracycline and sulfanilamide and caffeine. And in each one of these cases, we found that these compounds were easily photodegradable using the batch process. Our hope is to be able to apply these processes to our continuous flow photoreactor and then modify and optimize our photoreactor so that it can be more properly placed into a water treatment regimen to effectively address these contaminants. Thank you for your time.